Good day, students. On this clip, we're going to be going over two examples on how to graph sine and cosine functions. We're going to be adding some analytical components in our solution, so I'll be ready for that. So let's write down the instruction for the notes for today. You're to write the given functions, or the given function in transformational form. Graph and find the intervals of increasing, decreasing, max, maximum, minimum, concavity, and point of inflection. Points of inflection. Okay? So these are the things we're going to be doing in today's example problems. Let's take a look at question number 1. We have the trig function y equals -4 cosine x. Okay? Alright. Let's express this function in transformational form. In transformational form, it can be expressed as y minus 0 equals -4 cosine 1 times x minus 0. Okay? Alright, with this information, we can find all the relevant components for graphing. Let's start by finding out the new origin. Okay, so the new origin is hk. We know that this is h right here, and this is k, this is a, and this is b. Alright, so hk is going to be 0, 0, which is the new origin. That tells us the phase shift and vertical shift. The phase shift is the x coordinate of your new origin. So the phase shift is 0, actually is none, because there is no movement in the x direction from the origin. The vertical shift is none also, because there are no movements side to side. Alright, so now we need to find the amplitude. Amplitude of our function is the absolute value of a, which is the absolute value of -4, which equals 4. The period. The period of the function, you use the formula 2 pi over b. In this case, b is 1, so we're going to do 2 pi over 1, which is just 2 pi. Alright, and that's going side to side. And it also tells me that 4 ticks equals 2 pi. Okay, when we're doing a calibration of our x-axis, we'll use this piece of information. Now, the frequency is the reciprocal of the period, which is b over 2 pi. Is going to be 1 over 2 pi. Alright, and then let's not forget that our amplitude goes up and down. Okay, let's go ahead and set up our graph and draw it. So there goes the x-axis, and then my y-axis. So I know that, let me pause this. Yeah, so let's add some piece of information to this graph. Let's graph this function on the interval. Let's graph this on. Add this to the question. On this interval on bracket -pi over 2 all the way to pi. Okay, let's place this constraint on our domain as opposed to the whole thing. Alright, let's also include the window so that we know that what the window looks like. So for a window, we're going to be starting from 0, 0. We're going to go up and down 4 units, 4 units up, 4 units down. So my mean is going to be -4 and my max is going to be 4. Side to side, we're going to go 2 pi units. So 2 pi plus 0 is 2 pi. And to the left, we're going to go 2 pi units also, -2 pi. So we have -2 pi. All right, so let's calibrate our axis. We're going to have 4 tick marks equals a period. So let's use 2 boxes for a tick mark in this example. So we'll have 1, 2, 3, 4. All right, that's 2 pi. So if that's 2 pi, this has to be pi. And this right here is pi over 2. And this is 3 pi over 2. Going to the left direction, 1, 2, 3, 4 is -2 pi. And if 4 tick marks is -2 pi, then that means this is -pi, and this is -pi over 2, and this right here is -3 pi over 2. Okay? Alright, so let's call 3 tick marks our maximum. This is our max. And since our amplitude is 4 units, so we're going to have 4 units up, and then 1, 2, 3, -4 downstairs from the center. That's our minimum. Alright? So let's put in our boundaries. So this is our maximum upper constraint, and then this is our minimum. This is how low the graph can go. Alright? Let's go ahead and indicate that. This is our max, and this is our min. Alright, now let's grab the points for this graph. We're graphing the cosine function from -pi over 2 to pi. Remember that the sine function is like an S, and the cosine function is like your cup. Okay, so we're going to be using this one in this example. So let's put in the points. Always start from your origin when you're graphing your points, either the center, the max, or the min. In this problem, we have a negative cosine. So what does a negative cosine mean? A negative cosine basically means that our cup is going to be inverted. So instead of it opening up, our cup will open down like this. Alright, so that's what our cup will look like for negative cosine. And if we had negative sign, it just flips our S. Instead of the S going up, the S will go in the other direction. Okay? So let's put in the points for that. So instead of starting at a maximum, we're going to start at a minimum. And then we're going to go all the way to pi. So max, now we min, center, max. Alright, following that pattern. And then going in the other direction, back to the center. Connecting the dots will give me my result. Alright, so let's look at the configuration of the points to see which is open and which is closed. This is a bracket, so that means this is closed circle. This is parentheses, that means this is open circle. So let's go ahead and indicate that. This is going to be closed. And that terminal point, this is going to be an open circle. Okay, right here. So let's connect it. So we're going to go curve out the min, straight towards the center, straight out the center, and then curve at the max. And then here we just curve from the straight towards the, do that again, straight out of the center, and then curve towards the min, like that. All right, so there you have it. Okay, so now we're going to start finding the relevant information. So first thing we want to do is we want to find where it's increasing. Increasing, where is the function going up? It's increasing from 0 all the way to pi. See, from here to here is going up, so it's increasing from 0 all the way to pi. Where is the function decreasing? Where is it decreasing on? It's decreasing where is it going down? Assuming you're an ant walking or a car driving, where is the car going downhill? From here to here. Remember, you're going in this direction. So if you go in this direction, you're going down from -pi over 2 to 0. So from -pi over 2 included all the way to 0. We're including -pi over 2 because it's not a max or min. Okay, it's an interior point. We cannot include this because at this point it's neither increasing nor decreasing. It has no direction here. It's just neutral. Okay. Alright, so that goes increasing and decreasing. Now where's our max? The max is the highest point on the graph. The highest point of the graph is an open circle, so in this graph there is no maximum. All right. Minimum. What's the lowest point on the graph? Okay, notice the graph touches the minimum here, so the minimum value is -4. So the minimum is y equals -4. Our concavity. When is the graph concave up? When is it facing upwards and curving upwards? You see it curves upwards from -π/2 to π/2. So parenthesis -π/2 all the way to π/2. Where is it concave down? Where does it cave downwards? Concave down. Look at the graph. You notice it caves downwards from π/2 all the way to π. So from π/2 all the way to π. Where is our point of inflection? Inflection? Inflection happens where the concavity changes. So it was concave up here, and then it switched to concave down here. So a point of inflection happens at the center. Okay, let me indicate that for you. So from this point to this point, it was concave up, and then from this point to this point, it was concave down. Where did the switch happen? The switch happened right here. So there goes your inflection point. Okay? So point of inflection is this value, which is x equals π/2. Alright? Had it been the graph continued over here and curved the other direction, it will also be an inflection point. But there wasn't any concavity before this point. The graph starts from here, concave down, concave down, concave down. Concave up, concave up, concave up, and then switch to concave down, concave down, concave down. So this point is your point of inflection. Alright, so there you have it. Alright, now let's move on to question number 2. Alright, so for number 2, we have the function y equals -2 sine x. Okay? Alright, let's write it in transformational form. This is going to be y minus 0 equals -2 sine bracket 1 x minus 0. Alright? So we know that this right here is k, this is a, this is b, and this is h. Alright, so h and k is a new origin. Let's write that down. New origin is hk, which is 0, 0. Our phase shift is the x-coordinate of your new origin, which is 0. Actually, since it's 0, that means there's no shift, right? So no shift is like none. And then your vertical shift is the y-coordinate of the new origin. There is no movement in the y direction, so there is no shift up or down. Your amplitude. Your amplitude is the absolute value of a. In this case, a is -2, so absolute value of -2 is simply 2, so that's the displacement up and down from the central position. Alright, period. Our period is 2π/b. b is 1, so we're going to go 2π/1, which is equal to 2π, and that's side to side from the central position. Frequency. Frequency is the reciprocal of the period, b over 2π. In this case, it's going to be 1 over 2π. Alright, now let's set up our window and then go ahead and sketch our graph. So let me put the window over here. So window from the center, 0, 0. We're going to go to the right, 2π, and that takes me to 2π. And then to the left, -2π, takes me to -2π. We're going to go up or down. The amplitude, -2 down to -2, and then 2 up to 2. Okay, so there goes your window. Now let's add a domain constraint to our problem. So let's say we're graphing y equals -2 sine x on the interval from negative pi over 2 as less than x, and x is less than or equal to 2 pi. Okay, let's say this is a constraint on our domain. So let's go ahead and sketch that. So graph your x coordinate and your y coordinate. Okay, now let's for tick marks is going to be 2 pi because our period is 2 pi. So let's use 2 boxes for a tick. So 1, 2, 3, 4. That's 2 pi. Okay, that tells me that this is pi. And then going in the other direction, 1, 2, 3, 4. This is negative 2 pi. Okay, that means this is negative pi over 2. Remember, I'm starting from negative pi over 2 all the way to 2 pi. Okay, so all these other intermediate calibration values do not really matter. All right, so we're going to go up 3 boxes. Let's call 3 boxes our displacement up and down from the center. Our amplitude is value of 2, so this would be 2 units up and negative 2 down. So this is our maximum displacement from the center, and this is our minimum. Okay, let's go ahead and indicate what those are. So this is our max right here. This is the max, and this is the min. Okay, all right, now let's grab the points. What is our sine function going to look like? Let's do the orientation first and put in the points. Remember, sine is like the S, right? It's like an S. What if you have a negative sign? What is that going to look like? It's going to be the S reflected downwards, right? Something like this. So that's going to be the orientation of our sign. It's going to be the S flipped downwards. So when we put in the points, we're going to start from negative pi over 2 to 2 pi. But when graphing the points, we always want to start from the origin, okay? From the y-axis. All right, so starting from the center, we know that we have sine starts from the center. And then since it's a negative s, we're going to go down instead of up to the right. So go down. So center min, center max, back to the center. That completes a complete sine curve. And going in the other direction, since we went down to the right, we're going to go up to the left, to the max. Okay? Alright, this has no line right here, so that means this is an open circle. This has a line right here, that means this is a closed circle. Remember, this is your start and this is your stop. Okay? Let's put that there. Start, stop. Okay, now let's indicate the points. So this point right here is going to be open. So for the open circle here, the terminal point is closed, so I'm going to make this a closed circle. All right, so let's go ahead and draw our graph. Then we're going to start to do the analysis of the graph. Okay, so curve out the max, straight through the center, straight through the center. Curve out the min, curve out the min, straight through the center, straight out the center, curve out the max, curve out the max, straight to the center. Okay, so that goes your sine curve. All right, now let's do the analysis part. Where is the graph increasing? Increasing? Where is it going upwards? Let's see, you're in a car driving. Where is the car going up? It's increasing from here. Oh, I think I need to put this now. Pi over 2, 3 pi over 2. It's increasing from here all the way there because your car is facing up. It's going uphill. So it's increasing from parentheses pi over 2 all the way to 3 pi over 2. At these two endpoints, this is a min and that's the max. An extreme is neither increasing nor decreasing. Hence, we use a parenthesis. Decreasing. Where is the car facing down, or where is the car going downhill? It's going downhill from here to here, and also is going downhill from here to here, right here, okay? So it's going downhill from here to here, and then going downhill from there to there. So it's decreasing from pi over 2 all the way down to, negative pi over 2 all the way down to pi over 2. Alright, and then we're going to unite that with the next interval, which is from 3 pi over 2 all the way to 2 pi. Alright, so there goes the decreasing value. Okay, next thing we're going to look for is the maximum. Maximum. a high point of the graph. This maximum, it doesn't count because it's an open circle. This counts, so the maximum is going to be 2. So y equals 2. And then the minimum is a low point on the graph. Okay, so this is a low point right here. -2 is your minimum. So your minimum is y equals -2. Okay? Now let's deal with the concavity. When does the graph concave up? When does it cave up? Take a look at the graph. When does it cave up? You notice it caves up from, let me erase this area right here. I think better still, instead of scrolling up and down, let me put the concavity right here. Alright, so concave up. The graph caves up from this point right here all the way to this point. You see how it's caving up? So this one is concave up right here. Alright, so it's concave up from 0 all the way to pi. And then concave down. When does it cave down? You notice it caves down here, it's bending downwards. So this is concave down, CD. And it's also concave down on the rest of the interval right here, concave down. You see how it's caving downwards, right? It curves downwards. The curvature is facing downwards. So there's going to be 2 intervals. We're going to stitch them. So concave down from -pi/2, from -pi/2 to 0. And then union pi to 2 pi. That goes a concave down. Next thing we need is the point of inflection. At what point does the concavity change? It changed twice, if you notice. It changed from here, concave down to concave up at 0. This is a point of inflection. And then this point also is another point of inflection, all right? So, inflection. So let's indicate those 2 points. Inflection. So the first one is x equals 0. And the second one is x equals pi. Okay, so those are 2 points of inflection. So there you have it. All right. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel just by clicking up here. More videos can be found on microserve.com. Thanks again and have a wonderful day.